So what we're about to get into, let me just say a phrase and see what kind of reaction I get. Side, angle, side. Is there any reaction? I feel some reactions. Do some of you guys have no reaction to that? Side, angle, side? Like, is that part of the square dance? What is that, John? Everybody, side, angle, side. Huh? What is that related to?
Triangles.
What about triangles? Do you remember? We're not getting trigonometry. Is that what you said, cosine?
It's like a different kind of. There's like different types. Angle, side. Well, it's like what you're given.
Angle, side, side. Okay, so what do you guys feel about this? Everybody's got paper out, yes? Okay, so let me see if I want to get everybody kind of ready for what we're about to do. If you brought your kits, could you get and you have a protractor in your kit, can you get that out? Also, these little guys right here, the ones that kind of connect and do this weird thing. Yes? Okay. Now, I have, let me see. Should have some, oh, I have one of these, that's true. You get over there. You have been picked apart. Oh, there's a little protractor in there. Aha! Right. You got nothing for me. What is this? Aha! Yes, okay. Let's see if I have to group you guys up for this. 1, 2, 3, 4. How many people would need to borrow some materials? Go ahead, raise them up proud. 1, 2, 3, 4, 5, 6. Okay, not too bad. You guys could share up there, I think, yes? You guys are very good. Oh, give me my own. Okay, you're okay. Alright, so. Do that again, I'm sorry. Raise your hand again. You have enough like that. You can borrow some from Mary. She's got plenty. Oh, who else? Oh, you don't have the. Oh, sorry. So let me see. You guys need to share. You're good. And then, can you guys share this little stuff? Thank you. And then protractor, sorry. Protractor. Ooh, it's got a little piece. Oh, you got protractor. Look at that. Protractor. Okay, all right. So first, before we use the protractor, get these little guys out here. All right, some of you guys, if you don't have enough little parts, ask if you could borrow some from somebody else. Some of those bags I just handed out have a ton of these in them, so you should be able to borrow. You guys have this big red dude. It's probably the longest bit, yes? See if this will do what I want. I think so. Yes. Almost. Okay. Let's use you. Yes, green dude will work fine. All right. Don't know if the colors are translating well. So the big red dude, the big longest dude, big red dude. Big red. Is blue? Blue's a little short. Okay, good. And then a green dude. And I think, if I remember correctly, it should list on the bit. Yes, so this one is 14.14 centimeters. This one is, because everybody's desperately wondering, 8.66 centimeters. And this one here is, where are you, little dude? Oh, you've been roughed up.
5 centimeters.
Thank you. This one's been worn off. There he is. 5. You can barely see him. Okay. Can you construct a triangle out of these bits?
No.
Why not?
Because the two shorter lengths
Yes?
are shorter than the longest.
Yes, the two shorter lengths add up to be less than the longest. So if we try to do this, I can't even connect it there. Yes? Is that cool? What is that related to? We've said this before, but I don't know if I made a huge deal out of this. But if I'm given a triangle of 3 different lengths, if I'm given 3 different line segments, what must be true about any 2 of them?
Must be less than
Yeah, so this guy's problem is these 2 add up to be less than this. So obviously it can't be less than. Any 2 must add up to be greater than the third one. Are you guys all with me? And I want this to make physical sense. If I had a segment that was 3 centimeters long, and a segment that's 4 centimeters long, and one that's 7 centimeters long, the only way I could connect them is to make them a single straight line. The minute I try to pull this dude up, now it's going to be even shorter here, yes? So any 2 of them must add up to be more than the third. That allows it to have that little bump up, so it's not a flat line. Does that make any sense? No, Jeff, you suck. So what was it? It was 5, 8.66, and I think it was 1414? Thank you. And of course, these 2 add up to be, oh, poor little guy. What do these 2 add up to be? You can do it. These 2 add up to be 13.66. Oops. Okay, good. All right, so that's the first kind of level of physical limitation, right? It's not just theoretical. You can actually see it happening. So let's try again. Let's try to do it with the purple and the green. Purple and the green. Get on there. All right. It's kind of satisfying when you actually get it to click. Yay! It made a triangle. It made a triangle. So, everybody with me? That's very basic. So obviously, the purple, can somebody see what that size is for the purple? I should have put colors up there instead of letters.
7.07.
So we replaced 5 with 7 point blah blah blah, and 7 point blah 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 plus 8 point blah 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 is at least 15 point blah blah blah. Yes. Which is bigger than the last one. You guys, is everybody with me? Any 2 potential side lengths for a triangle must add up to be more than the last one. For any pairing you can think of. So normally what we do is, whatever the longest one is, we just kind of course it plus something is going to be bigger than the other one. So I just take the longest one aside and think about the two shorter ones. Do they add up to be more than the longer side? If they don't, I can't do this yet. I can't do that. Make a triangle. Okay. Now, would you agree if everybody did this with me? I see a bunch of triangles. This makes me so happy. Would you agree? This is going to sound very silly. Erica, you're holding a triangle, yes? I like it. Doesn't make a little note when you did it, I'm sorry. You're holding a triangle, okay. Are your triangles the same triangle? Be very careful with what I'm saying. Are they the same triangle? No, because you're holding one and you're holding. It can't be the same triangle, correct? You with me? What do you want to call your triangle? Give me the vertices. ABC, cool. So Erica is keeping it very. Now I got the song that ABC. So Erica's got triangle ABC. Laura, what's your triangle? DEF. No way. Shit, where'd that come from?
You got a death triangle, like, all right.
So, those are obviously different triangles. They exist in two different places in space. Correct? But what is it about them? What must be true about them? They're not the same triangle. They have the same, why do they have the same angles? They have the same side lengths, which is that idea of the mouth opening. I think I've told you guys that. I know it's weird, I'm sorry. But to me, it just makes sense. A little angle makes a mouth, and then it tells me how big the stick is. Right? So if all the sticks are the same size, those angles across them must be the same. But you would agree with me that in some sense, those triangles are the same, but they're not the same triangles. So I cannot say triangle ABC equals triangle DEF, because that would mean that's the same triangle, like it's gone through time and moved over to Eric. Are you guys kind of with me? So if Laura does this to hers, that one will have a little thing show up on it.
No.
I'm sorry, it's time travel. Okay. Are you guys kind of with me? I know we're going deep into something that seems very, very straightforward, but we're about to get into other things. So can you tell me, if I gave everybody, if I said everybody get this side length, this side, everybody gets the same exact 3 side lengths, is it possible for somebody to construct a triangle that is not the same as others? Could somebody in here, right now, did anybody make a triangle that is fundamentally different from that one? And don't tell me, well, Jeff, my triangle has the purple on the other side. I'm like, all right, that's great. I put mine like this, Jeff, because I'm weird. Okay, you guys kind of with me? So they're not the same. There is a word we've used before when we have things that have the same measure. Congruent, I love it. So these two triangles are congruent. Because, like you started saying, each of their angles are congruent. And each of their sides are congruent. Now obviously the sides are congruent, because we started with that, correct? So if anybody in the universe constructs a triangle from the same side lengths, they're going to effectively create a congruent triangle to this. Okay, I think you've beat that into the floor now, Jeff. Okay. How do I capture that mathematically? Because, of course, math people can't just leave things well enough. We have to make all these stupid little symbols. So we're going to say triangle, Jeff, ABC. It does not equal, it's congruent to triangle DEF. I believe that's the way. There are other symbols for congruence, but if I remember correctly, that's what this book does. Let me double check. Yes, good. Okay. All right, fascinating. Now here's the question though, and here's where your protractors are gonna have to come into play. And actually, can you guys take a moment? Can everybody slap their triangle down like this? Yes? So if this was Erica's triangle, let's say this would be A, this would be B, this would be C, yes? And then if this is Laura's triangle, D, E, F. So real quick, just to remind you guys about an idea that came before. So this was Laura's, it would be D, E, F, potentially. I don't know if she would agree. See if she has strong feelings. One, no, Jeff. The green and red sun should be the E. No, okay. So agree with me. There's an idea that has come up before in this class about a one-to-one correspondence. Do you all agree every triangle I can make a one-to-one correspondence between vertices? Because every triangle's got 3 vertices. When I construct a one-to-one correspondence between these, so like D corresponds with A, B corresponds with E, and C corresponds with F, the minute I establish the vertices that correspond, then I know that angle B, the measure of angle B, equals the measure of angle E, for example, right? Wow, look at that E. Sorry. It's a little mutant E. It's got an extra little thing. Right, that's freaking me out. That's so much better. Okay. Angle, side BC is equal to side
EF, yes? Or it's congruence, but the measure of BC is equal to the measure of EF. And I can't remember, did we in this class, you have to excuse me, because I'm teaching 3 classes that all talk about the lengths of things in 3 different ways, which is fantastic. Did we actually identify this symbol here as meaning the length of a segment, or I don't think so. This is absolute value symbol, yes? Oh, we did it with, yes, we did with the number line stuff where we figured out the distance between 2 points. Okay, so I'd say the measure of BC is equal to the measure of EF because I corresponded B with E and C with F. Is everybody kind of with me on what's happening? So the one-to-one correspondence tells me which letter is effectively the same as the other one, and then any line segment I make with one group of letters is congruent to the line segment I make with the corresponding letters. So that's a whole long-ass way to say every side is the same in the triangles and measures. Damn, Jeff. So do you all agree that if I am building triangles, if I have a whole bunch of people in this triangle factory, yes, no idea why this is happening, okay, but we're making triangles, and I give everybody the exact same side lengths to make for every triangle, they're all going to be congruent, correct? Therefore, and here's what the letters, the SAS and the ASA and all that kind of crap, if I am given the same side lengths, I will end up with congruent triangles. That is not ground shaking, which is why I wanted to start here. Okay, let me stop for a minute. Does that start to, so we're not gonna do what you did in geometry. We're not gonna get deep into like, I don't know if you remember writing the proofs and all that kind of stuff. We're actually gonna go the other way. We're gonna do a lot more construction of shapes and so forth. Some of you guys might remember, like you had in geometry a lot of proofs. No? Okay. Maybe you escaped somehow. I had this guy who was like 7 years past when he should have retired. His name was Dr. Hooker, and he would walk around the room with his hands like down the back of his pants, staring at the ceiling. So, you know, and I'm like, oh my God, anyway, sorry, just vivid memories. Somebody with me. So if I have 2 triangles and they have here, Jeff, draw the situation. If I have triangle JEF, and I have triangle MAX, and I know that JE equals MA, and I know that EF equals AX, and I know that JF equals MX. What must be true? Huh? Sure. Which means what? Those 2 triangles are congruent. I love it. So side, side, side is a quick way to reference a situation in which 2 triangles must be congruent. Is that cool? So then the question becomes, and obviously it's been given away a little bit already. What's kind of like the minimum number of elements of a triangle I have to be told, and it forces it to be congruent to anything else that has that? Does what I just say make sense? If I tell you, I want you to construct a triangle using this side length, this angle, and this side length, does every triangle made matching just those 3 have to be congruent to every other? Does that make sense? So think of it as we're given these parts and we're trying to construct it. If one part, now being given side lengths is very physical. We got little bits, look, we got little things, you can hold it, you can snap it, you can make, there's your side length. If I give you an angle measure, you can't hold that shit. Not until you construct something, then you can hold it, yes? I don't know if you guys are with me or not. So if I give you an angle measure, it's not something you can put in your hand. So how the shit do you deal with it? So let's say this. Is everybody cool with this? On one level, this is just if I can only make one triangle from 3 sides if a triangle exists. So what if instead I told you, oh shoot, that's right, I meant to do this earlier. I can do it now. What if I gave you a side length, the angle next to it, and another side? So what I mean is, what if I gave you a side length, the angle, and the other side? So that angle is literally between those 2 sides, which is why we put it that way. Is that cool? The angle is literally between the 2 sides I gave you. Are y'all with me? Okay. So here's what we can do. Oh, that's going to work, Jeff. It will now. Sort of. Hold on. Shit. Sorry. There's something I meant to do earlier and I completely forgot. So what if I tell you I'm going to give you the yellow and the blue? Now, listen. I want to use something concrete for this. The last side might not be something you have. Are you with me? So let's see if you guys get what I'm saying. What if I said, I want you to have a blue side and a yellow side, and I want the angle between. So let's do this. Everybody take your protractor. I don't know how many of you guys have never used a protractor before, but we're about to use it. How many of you guys have never ever used a protractor? Neat. Okay. How many of you guys did but forgot about it? No, I'm joking. No, you haven't? Okay. So here's how you do this. This effectively acts like the origin of a coordinate system. So this is kind of like my x-axis, and this is my y-axis here. Is that so far so good? So if I wanted to draw, so let's do this. Let's do this first. Can everybody take the protractor and just draw a line? Holy shit, Jeff. Jeff's going to try this again. This feels just like I used to be when I was in this grade. Jeff, turn your paper over. Okay, teacher. So I'm going to draw. Got to hold everywhere. Draw a line. Wah! Okay, good. Now, can you please line up, see this line here around the hole? Line that up with your line as best you can. What sucks is the minute I lift my finger, it's going to, oh, okay. Is everybody with me? So you have a line drawn, you've lined up the line. So real quick, just to show you. Does everybody see the line around the hole? Does everybody have this kind of protractor? Do you have this kind of thing here? Do you have something similar? Okay. As long as you have something that enables you to line this up. Okay. Now let's say I wanted to construct a 70-degree angle. So protractors are good for measuring angles, but I'm trying to construct angles. How the shit would I create a 70-degree angle? What would I do?
Create a mark where the 70 is.
Holy shit. Sorry. Yeah, I'm sure you guys are like, well, just put a little mark. So it doesn't matter which side. Pull that sucker down. I'm going to put them right there, just because. And real quick, do you see above this, the 110? That just means if you're measuring going this way. Okay, right? So we're looking at this guy, 70. If I put a mark here, I still would make a 70-degree angle. It would just be facing the other way. And now you just, oh shit, Jeff. You gotta be very careful. You should put a point right there. There we go. So you know where the middle of that is. And now you got this. Wow! That's pretty good. That's pretty close. So obviously, whenever we do this, we're only human, after all. We're gonna make mistakes. Yes? Oh my god, I know that all too well. Well, that's really good. That's pretty good. That's a 70-degree angle. What do you want? So let's try this. Yeah. So if I gave you You can also, does everybody have a protractor that's got a little ruler on the bottom? Okay, thank you. I couldn't remember if there were some kinds that didn't. If I measure this out, let's say that one side is 2 inches, yes? So that side would stop right there. Is that cool? And then the other side, let's say, is 1 inch. So this happens often when you are constructing a triangle, and at least one of the things you're given is an angle. You're going to have to kind of like draw sides further out, and then come back into my triangle, and have to chop some of my line off, but it's okay. So let me label it, sorry. This was 2. This was 1. And this was 70 degrees. So I'm given a side, the angle, and the other side. Could I make a triangle? I'd have to be given what to make a triangle? Huh? The angle is going to come out naturally. And here's what you need to remember. What's the only things that must be a certain size? Those 3 things. Everything else can be whatever they need to be. You with me? So if you're in this factory and you put this down, and you're like, hey, foreman, I need this, how can you, what are you going to tell me? What's the last thing you need to make this triangle? How long of a side do you need? True, but be specific. What is that? Let's see, it's about right there. I don't care that much, but that's roughly, let's see if we can do this. Remember, this is cutting it in fourths right here. This big long one is fourths. I don't know if you guys can see this. Let me zoom in a little more. Oh my God, I can get way in there. Okay. Come to me. Okay. So this is obviously a half, yes? This is a fourth. The next step down is an eighth, and then it goes a 16th. You guys all with me? If you count it, 1, 2, 3, 4, 5, 6, 7, 8. Now it'd be 16 of the littlest ones. So that's 1/16. You with me? So what does it look like? Yours might be a little different because my hand was a little shaky. Do you see how I didn't really go through the middle at that point? It doesn't matter. But to me, it looks like I'm going to need, let's see, 8/16, 9, 10, 11, 12, 13/16. I'm going to need 1 and 13/16. Are you guys all with me? We're not going to very often get to that level of detail. Are you guys? You're not going to be doing this a ton. You're going, what is that? Is that 1 and 7/16? You're not going to be doing that a lot. Yes? And I don't think you sound like that. Most. So I just wanted to do this one just to show you fully. All right, so here's the more important question. If we all measured everything perfectly, could any of us have made a triangle that wasn't congruent to anybody else's? Given the side, the angle, and the side, doesn't that just leave room for exactly one side? I mean, there's no other side length you could make. The minute I drew that side in, what else did I lock down that somebody was asking me about earlier? This angle, this angle. Can you guys all take a minute? And again, did what we just do, was it perfect? So we're going to get off our backs and we're going to see if it's close. Can you all measure the other 2 angles we just created? So now we're using the protractor for the more immediate purpose of its existence. Measuring angles that already exist. Here, Jeff, you're supposed to be doing it. Oh, yeah. Wait. You're only human after all. So let's see, this one looks to be Is that 8? It's almost exactly 80. Is that right? That's crazy. And then this one, I get, if I extend that out, that's almost 30. Almost 30. So I get roughly 80 and 30. Why is that good? Did you guys get roughly that too? Or roughly? Is everybody good? Everybody good? Let me know if you have any trouble with it, because I know some of us have not used protractors too much. Why is that good that I got those things? Equals 180, thank the gods. Which means our triangle actually exists. Yeah. So, real quick, before we go to another thing, obviously this is a side angle side. I was given, in this specific instance, I was given 1, 70 degrees, and 2. Sorry, I'm zoomed way the hell in. Can you guys do everything we just did? But now I want you to do it with 3, 20 degrees, and what you got, Jeff? 2. Let's not make it too crazy. So when you draw your lines, make them kind of long, because you can always chop them off. It's not easy to extend them after the fact, right? Yeah, this is good, okay. Should I send an email out about Wednesday being a day off? I should have just let people that aren't here kind of come to, oops, should have opened. Okay. We'll see if future Jeff remembers to do that. Future Jeff. Here, I'm gonna freeze this, and I'm gonna try to do this here. Come here. Do 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 do. Bam 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 bam. Bam 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 bam. Shut up, Jeff. Okay. Ay ay ay. Okay. Well, shit. It's okay, Jeff. Oh, the poor little 3 dude. I see he's there. So that is pretty much right there. That's crazy. And the 2 dude. There we go. Here's what mine looks like so far. I just decided to put the 3 up there because I didn't make this one long enough in the first place. Poor little Jeff. So you guys might have the 2 up top, it doesn't matter, you just kind of put a mirror image or something. So you can see that the last side and the last 2 angles are determined. That's an important word, determined. Having those 3 things identified, it is impossible to not construct a congruent triangle to whoever else does the same thing. Do you all agree? Do you all concur? Okay. Because the minute I draw those things out, there's a side that's determined for me already. I don't get to choose it. So let's see. Come. Rawr. What'd you guys get for the side length of the last dude? The last side? Come here. Come here. I swear, quattro. Okay. Sorry? Yeah, one. I got, what did I get? I might get something different. I got 1 and, oh yeah, 1, 2, 3/8. Yeah, cool. Real quick, really silly question. Why don't those side lengths follow Pythagorean theorem?
Because it's not a right.
It's not a right triangle. I love it. Okay, so people sometimes get, you know, they remember Pythagorean, they see a triangle, and they're like, wait a minute, why? Okay. And then your angles. Did anybody get the big ass angle here? What do I get? Ooh. I get like, what'd you guys get for this angle? Anybody? Nobody? Oh, I'm sorry, you guys are like, the big one, the big angle. That's all I had to say. I was kind of hiding it from you, not on purpose, but then it, there. Yeah, so I'm gonna say mine is 128, it looks like. If I'm really being pedantic. Mine looks to be 128. Yours might be different because our lines might be slightly not the same. Because again, we're human. So everybody get around 130 for that one? Okay, and then the last dude, already should be able to figure out what it's supposed to be. Well, let's see what it is. I'll do it this way, just to show you. This one comes out to be about 32. So this is, I can do it this way. This is why if I have an angle that's kind of like facing the other way, then I can use this. I just have to read the other side, right? Not a major deal. Or I could have just turned my whole paper around and done it that way, but apparently I was being exceptionally lazy. Okay. Now, just to tell you, and we're not going to do this. Somebody remind me, what's the Pythagorean theorem again?
A squared plus b squared is
There does exist an adjustment to that makes it work for every triangle ever. And it's something called the law of cosines. Something you might have learned in trigonometry. What's really cool about that is it's a squared plus b squared, and then it's minus like 2ab cosine of c. So again, we're not doing trig in this class, don't worry, I just wanted to let you know there is an extension to the Pythagorean theorem that works for every triangle. So you can look at the Pythagorean theorem as a specific application of that law right here. When the angle is 90, then the minus part goes away, it becomes 0. Okay. If anybody's, have any of you guys, yeah, you must have done some trig. Yes? I'm not gonna, don't worry, I'm not gonna put trig on the quiz or test. Do you guys remember what cosine of 90 degrees was? Here's the way, real quick, here's the way. Cosine likes x, sine likes y. So at 0 degrees, cosine is 1. At 90 degrees, sine is 1. At 90 degrees, cosine is 0. Because there's no x piece. So cosine of 90 is 0. So that, I've said too much. I'm so sorry. This is nothing you're responsible for. I'll stop. Now, is anyone at all curious? What do we have so far that works? Side angle side leads to congruent triangles. If I have two triangles and I know that two sides and the included angle, does it make sense when I say that? Two sides and the included angle, like it's the angle that those two sides' mouth makes. If I know those are the same, that means the entire triangle is congruent to the other. So that would be this. And earlier we saw this one, which is almost silly. If somebody gives me the same three sides, I'm going to make the same triangle. What do you want from me? Or a congruent triangle, if I want to be more precise. Okay. Congruent. So then the question is now, well, what the shit else works, Jeff? And what doesn't work, Jeff? Obviously, if I don't give you enough, if I just gave you two sides. So guys, if I just said, make a triangle, everybody do this one. Get a blank piece of paper. I want you to make a triangle. One side is 1 inch long, and another side is 1.5 inches long. That's all you need. I just want a triangle. One side is 1 inch long, and the other side is 1.5 inches long. Or I'm sorry. One side is 1 inch long, and another side is 1.5 inches long. That's all I'm telling you. That seems too long, Joe. You sure about that? Maybe. Mm-hmm. Yep, yep. Yep, okay. Okay, so once you've constructed your triangle, can you please measure the angle between the sides I gave you? So for example, this is my triangle. So the angle between the sides I was given looks to be, well, that's cool. Looks to be about 130 degrees. Neato. Does everybody's triangle look like mine? Could somebody, does anybody feel comfortable? So let me put your triangle on the overhead, just real quick. Anybody? Or y'all like, it's mine, man. Can't see it. Nobody? No. Ooh. I think this might be related to more people's. Did more of yours look like that one? Anybody? Yeah, this is kind of like the triangle I would expect. This kind of makes sense. More contained. Mine went more like out. This is more contained, and this matches more like our template of a triangle that we have in our head. And your angle, what's this?
133.
No, be careful, be careful. There's no way that could be 133, right? Sorry, Adrian, I don't mean to call you out.
I don't know.
This is
No, I
133.
think I used it off.
Yeah. So if you do it this way, you've got to use, I'm sorry, man, you're good. I don't mean to put you on the spot.
50.
Yeah. So it's got to be the complement of this, right? I'm sorry, the supplement of this. So it'd be 40 something. Let's see. Well, 30 something. So let's see, if I do this, that's 140 something. So let's see, it's actually 32 degrees roughly? Yeah. All right. Did anybody else get a different angle than 130 or 32? You don't have to share me your triangle, just tell me. Did everybody measure their angle? What'd you get, Phil? The one angle I asked you to measure. The one that's between the two sides I gave you? 75 degrees. 50. Anybody else? Okay, I'll stop. You guys are like, come on. All right. So, obviously then, if I only give you two sides, there's a wide range of triangles it could be. Yes? Could that third side, no, this is going to be a silly question, could that third side be as long as it wants to be? No. Right? Because if you put these flat, if you made sort of a silly triangle where this was a one this way and 1.5 this way, that's not a triangle. But like the last side would be 2.5 inches long, yes? So remember, if you take any two sides, they must add up to be more than the last side. So what is 1 plus 1.5? 2.5. So what is the absolute longest the third side could be? Just under 2.5. Does that make sense? Okay, I like it. So for my side, I got, and I'm pushing my luck today with your patience. I appreciate it. My side, I got looks to be 2.25. Holy shit, that's neat. I think I got exactly 2.25 inches. Neat. Okay. So, continuing our exploration. We're going to make this list a little bit longer. Let's do this one. I want you to use, so let's see if I can explain this somehow. I'm going to have to give you a picture for this. I'm going to give you a side length of 1.5 inches, another side length of my S's and my 5's, I know, of 2 inches, and then the angle not between the two. So let me show you what I mean. So here's one side, here's the other side, and here's the angle I'm talking about. That's where things get weird. So I want the angle to be, what you got, Jeff? I don't know, buddy. 36 degrees. So here's kind of, all right, this one's definitely trippy. Let me see, what's another way I could show you? Let me think. This one's a little trippy. So do you see how this angle, okay, this situation's a little bit weird. This angle here, let me give these names. Let me call this A, B, C. Angle B could be anything. Are you with me? Because I only said angle A had to be 36 degrees, correct? Do you all start to see how this one's tricky? Because having an angle is sort of, it's like, if I wanted, well, it's like a dangling participle. I don't know why they need one. Probably because they got one English iron. That last angle is kind of like off by its own. It's kind of like just hanging there. There will be a side coming off of AB to make that angle, yes? So here's one way you could do this. Let me kind of help you guys out, because this one's tricky. Where's my glasses? Oh, come here. All right. I can draw AB. Let's say that's the 1.5, let's say. So this is A, B, and I'll make this 1.5 inches. I can then make sure my angle is correct. So I'm going to put a little dot here. Sorry. And my angle was supposed to be, what, 36 degrees? Why'd you pick that, Jeff? I don't know. Leave me alone. 36, so it's going to be right there. Is that cool, everybody? 36 degrees. I have no idea how long this is going to be, so I'm just going to kind of make it nice and long. Let's see, come here. Okay. Because that side could be as long as it needs to be, yes? So here's the cool thing. Has everybody got that so far? Are you guys playing along with me? Some of you guys are just staring at me. I really want this to make sense. Why did I make this side so long? Is this even the side? The only reason this is here is because that makes this 36 degrees, yes? Is that cool? I know that has to be 36 degrees. Is that cool? I was told I had to use 36 degrees. The other two angles could be whatever the shit. I was told I had to use this side of 1.5 inches. So now I need a 2-inch side. Yes? Oh, here it is. So do you see how there's really only one way? I really want you guys to see. The last side has to go in here like this somehow, yes? To make a triangle, I can make a triangle like this. I can make a triangle like that. I can even make a triangle like that, yes? Do you guys see what I mean? If I told you to draw in the last side, but some of you guys could draw this side in, yay, but it's got to be 2 inches, yes? So that tells me it's got to be, Jeff, do it from this way, yeah. 2 inches. Oh, that's funny how it's almost exactly there. That's crazy. That's weird. That's going to trip me out. Sorry. It's almost exactly my little dot that I made earlier. All right, guys. How we doing? Okay. I like it. So far that seems to be like the only kind of triangle I can make. So let's change things up a little bit, because this one is weird. This one, when I teach this in my pre-calc class and other things, I actually kind of turn this around. But in high school, they don't want to do this, obviously. But I do this way because it helps people remember this is the one that is not guaranteed to make a congruent triangle. Okay. So here, instead of me trying to come up with an example on the fly, I'm going to pick one out of here. Do they even do this one? Or did they? Oh, they didn't even do this one, those jerks. Oh, they stayed away from it. All right, well, that sucks. So let me think. Okay. I can do this. What I need is, yes, what I need is, okay. That'll work. Okay, beautiful. So let's see if I can salvage this. So let's say I give you this. I give you 1.5 inches. What did you just do, Jeff? You did that. Beautiful. 1 inch and 36 degrees. Okay. I appreciate your patience. Stay with me. This is kind of cool. So you can do everything we just did. I could do the 1.5 inches. So 1.5 inches. To there, there's 1.5. I'm going to call this like that. Just like we had before. I could do the 36 degrees again. I could do 36 degrees. 36 degrees would be right here. Pop. And then I can make this just long just because it's just sitting there waiting. Poor little guy. Work with me. There we go. Okay. Now here's where things get freaky. So there's my 36 degrees. There's my 1.5. And now I want to put my last part down. Wherever I put my last part down is going to inform me about how long this side really is, what the other angles are. So here's where things get tricky. Here, can you guys do this? Here, you guys. Does everybody really understand what's happening? You have to draw in BC. You have to draw in BC, and it needs to be 1 inch. You with me? Angles could be whatever the shit they gotta be. Does everybody agree this is one side of the triangle? Does everybody agree this is another side of the triangle? I just don't know how long it's going to end up being. Is that cool? And that's why I just made it long, because I don't know. So can you intersect that line, BC, that's 1 inch long? So for example, if I make BC here, I suck. That's not 1 inch long. That's way too long. Yes? So I want you to draw in BC, but it's got to be 1 inch long. That's the part that my boss, my boss gave me to construct this triangle. Yes?
Do you have any extra protractors? This one's all faded.
Oh no, I'm sorry. I'll trade you, hold on. Where'd that put all my protractors? There they are. There we go. This one I think is really good, yeah, I'll trade you. This is a little smaller, but this is not faded. Yeah, okay, you're right, that size. Yeah, let me know if any of your parts are, well, that's gonna sound weird, any of your parts are defective. Let me know if any of your stuff in your kit is faded or doesn't click or whatever. So I feel like most of you guys probably drew, do you see how I'm doing 1 inch, yes? I know it says 5, but that's 1 inch, yes? So I'm gonna kind of dot that line in. Dot, Jeff. There you go, buddy. That works, yes? Did anybody do that? Isn't there another place you could put this side? Couldn't you swing this side here? Doesn't 1 inch work there? So I either get, let me see how I can identify this. I either get, here I'll put ABC and then I'll put ABD. There we go. So I either get ABC or I get ABD. Would you agree? Triangle ABC, they label this side, does have a 1 inch, a 1.5 inch, and then a 36-degree angle. Triangle ABC, yes? Doesn't triangle ABD also have 1 inch, 1.5 inch, 36 degrees? Yes? So if I give you a side, and then an angle off that last side, does every triangle made from that have to be congruent? No. So this is our first instance where I gave you 3 things. When I gave you only 2 sides, we ended up with everybody had a different triangle. I gave you side angle side, beautiful. I gave you side side side, beautiful. I gave you side side angle, shit. This situation is an asshole. That's why I like to call it the ASS. Because it opens the door. Now we just did an example where there was only 1 triangle, correct? Right before this. So it does not have to create congruent triangles if you follow SSM. So we're good to get. Does this sound at all familiar to anybody? A little bit? So you guys like, no, does it, even if it doesn't sound familiar, does it make sense? I like this idea. In fact, I think I can do it with the bits. Yeah. Let's see if we can do this with the bits. Can you recreate this? And what I mean by bits are these things, the little triangle sides. Let's see if we can recreate that situation from these. I think I did earlier, and now I gotta remember. So that means that you have a side, another side, and this angle up here is set. Which means this angle could be whatever it wants to be here, right? So it might be easier to look at it like this. So let me see. So this angle is set. So like if this angle was 90, I could make a triangle, yes? Because this angle could be whatever it wants to be. If this angle was 130 degrees, can I make a triangle? This angle right here. So I got this side, this angle. If this angle's too big, can I make a triangle? No. If it's too small. Now again, this side is set. So if it's too small, then I can't make a triangle. Are you guys at all with me? Now let me see. I don't know if I could do this on the fly. All right, I'm not going to try to do this on the fly. I think I did this earlier. I just can't remember which colors made this work. But you can recreate this little thing, and I love it because it's a work. You could do it, Jeff. Can you? We'll find out. It's an easier way to see this. I can't remember. So I can have, yeah, it's sort of like this situation right here. Sorry. Where I can come in like this and make a triangle, or I can go out like that and make a triangle. So if the green and the yellow are set, and this angle here is set, then I can make a triangle like this, or a triangle like that. So this sucker can swing. Here, pop it on there, buddy. There you go, Jeff. My parts don't work. Hold on. There. So the idea of swinging. So the blue is not set. This yellow has to be this long, and this green has to be this long. The blue is, I don't know yet. And this angle must be this angle. So I can make a triangle like that, or I can make a triangle like that. That triangle is the triangle that people don't think about. Why do you think that triangle, for very young kids, they might not even think that's a triangle? What's in a kid's head when you ask them to make a, what kind of picture would a kid draw when you say make a triangle? Equilateral, or something close to it, or at least isosceles, yes? There ain't no way, so I want to make sure you really understand the kind of triangle I'm talking about. I'm talking about this triangle. They might not even, depending on what level they're operating at, they might not even identify that as a triangle, yes? And then, of course, as they move further, they start to understand that meets the definition, blah, blah, blah. So that's why this situation is appropriately called an ass, because you get the normal one, but you don't think of swinging it in and get the other one. Then you might think, oh yeah, this will work, this always makes the same triangle. Nope, you could sometimes you could swing that in and make a whole other freaky little wedge of a triangle. Okay. Have I even looked at my notes? What did I want to say here? I haven't looked at my notes at all. It's neat. Blah, 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 blah. This is all good stuff, Jeff. Blah, 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 blah. Oh, so let's do this. One thing I want you to definitely do. I give you a rectangle. So everybody take a moment, draw a rectangle. Doesn't have to be perfect. We're not going to necessarily measure things. And then maybe do this a little bit nice, but it doesn't really matter. Draw in a diagonal. Can you prove to me, let's call this A, B, C, D. Is triangle ABC congruent to triangle, you could do it, Jeff, C, D, Jeff, you said C and you drew D, C, D, A. More generally, just are those two triangles I created, are they congruent? So what's the old, well, I'm going to leave it open like that. There's a few different ways to answer this. Well, that's true. Yeah. So just to come in with some suggestions. What are the only ways we know? Did I forget one? I might have. We have side, side, side. We have side, angle, side. Is that the other one we talked about? The one I think I left off was angle, side, angle. Thank you. Because I was so jazzed about the one the book doesn't even talk about. Well, shoot. But I mean, which of those applies here? So real quick, this is a rectangle. Side AB is congruent to side, holy shit. Side AD is congruent to side CB. Now, And the really silly thing is, side AC in one triangle is congruent to side AC in the other triangle, which is groundbreaking, right? Okay. They both share that side, so what's one thing you could use to prove this? Side. And I know I said we weren't going to have proofs, but this is not really a proof. You just say it follows side, side, side. Is there another way you could prove this? Yeah, side, angle, because this, of course, is 90. Side, angle, side. So you could say side CD congruent to side AB, angle D is congruent to angle B, side AD is congruent to side BC. One-to-one correspondence stuff going on. Those two triangles are congruent. Beautiful, beautiful, beautiful. So not full-blown proofs, but just little visual applications. So let's real quick talk about the one I left out. Angle, side, angle. This one is definitely trippy, but the weird thing is, how many angles, of course, did I give you with this? 2. So how many angles did I actually give you? 3. If you know any 2 angles in a triangle, you know the third. How do I construct this? This one's the hardest because angles are, by themselves, they don't exist until I give sides, right? I make an angle by giving sides. An angle just doesn't exist on its own. So I need somehow to have like a base here, and then I have an angle, a side, and an angle. So the side is between the 2 angles. I don't know if that makes any sense. So both angles use this side as a reference. So this must open this much, and this must open this much. Well, the minute this must open, let me see if you guys are cool with this. Let's do this for real. So let's do this together. So let's say I give you, what are you going to give, Jeff? Let's make something not too crazy. 40 degrees for one angle. Let me do it like this. Angle, side, angle. 40 degrees for one angle. You could do it, Jeff. Nothing too crazy. 2 inches for the side. And then, 25 degrees for the other angle. Okay. So here's one way to set this up. Can you all make a 2-inch line segment straight across your paper here? Woohoo! Now, here's where things get trippy, and this is where I should have given myself more room, but I think this will work. Yeah, this will be fine. One angle has to be 40 degrees, yes? So I'm going to come off of one side. So it's basically this. I'm just rotating it to make it a little bit easier for us to work with. So there's the side we made, and now we're going to make these 2 angles. I cannot make an angle unless I give 2 sides. I really want this to make sense. So just like before we made this long ass side, because I have no idea how long it's going to end up being, it just needed to exist to really make this angle exist. Yes? So I'm going to make a long ass side coming off here, but make it 25 degrees? Or 40 degrees for this one. Let's do 40 degrees. So 40 degrees here. So I'm going to make that kind of long. Oh, that's perfect, Jeff. You're doing great. Let's see. That's not so good, Jeff. There you go, buddy. This is great. Out here, that's fantastic. And then, so this is 40 degrees, and then 25 degrees from this guy. No, Jeff, no. There you go, buddy. So 25 degrees would be here. Woohoo! So this is 25. This was 2 inches. Do you all agree? Or let's see what you think. Do you think this one is going to be the situation where there could be more than one triangle? Does anybody's triangle look like that? That isn't proof, but it's pretty good evidence that you can only make one kind of triangle given those measurements. Do you guys kind of with me? Why does it make sense in a loose way? What does an angle really tell me? That how much the mouth opens, yes? So if I know how much that mouth opens, and I know how much that mouth opens, there's really only kind of one stick that could fit here and one stick that could fit there. So even though I'm only given one side, the mouth openings determines how long the other 2 sides are. So in a sense, this is almost side, 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 just not so overtly. Maybe. And then, of course, I could ask you to figure out how long the sides are and blah, 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 blah. Could somebody tell me, how could you use constructions like this to show Pythagorean theorem? That seems to be true. Obviously, this triangle wouldn't work for that, correct? What's the last angle in this triangle? We knew that before we even did it either. What is this angle up here? Huh? 115. Because of course they all have to make 180, blah, 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 blah. So of course, if I made a student, if I just made sure that one of the angles I gave them was 90, whatever triangle they end up with is going to be a right triangle. And they can physically measure the sides, and then they can see Pythagorean theorem actually working from their own constructed triangles. That's some old Greek dude from Bass going, A squared plus B. No. Right? It's trippy, like, okay. It's them constructing a triangle and going, holy shit, or maybe not holy shit. Teacher, holy shit. Going, whoa, look at that. It actually works with this old dude squaring and stuff. Maybe. So, what do we know definitely leads to congruent triangles? I'll start. Side, side, side. Side, angle, side. Angle, side. That one was right there. Good. And of course, what's the one that leads to potentially, it could lead to no answer, one answer, or 2 answers? Side, side, angle. Better known as angle, side, side. Because it is a bit of an ass. Yes, you're like, why can't you just... Okay. Cool. I think it's pretty good. I'll leave a little early today. Why not? Is anybody upset about that? You're like, come on, Jeff, you're pushing it, man. You're going to give us next time off and leave early today? We'll report you. Feel free. If you borrowed it, yeah, feel free. Report me. If you borrowed anything, could I get that back? Unless I swap with you. You can keep that back. No. Dear God, if you have any issues with teachers, you know you can report them.
No, so we actually break them on my.
Is that doing?
No, but
No.
like,
Oh.
it helps other kids not take that.
Oh, that's good. Although I think I've taught you guys about that. If I don't get some bad reviews, I feel like I'm not doing a good job. Because there are some students I want bad reviews. I don't know if you really understand what that means. Well, all right. Oh, these belong here. So I will see you again a week